Antonin Hamon. You graduated from the engineering school of IMT Alès in south of France in the field of risk management, and you're currently doing your PhD at the Lab of Sciences of Risk of this university. And today you're going to present us a crisis management training, implementation of a simulation exercise based on repetition of learning sequences. Kind of a shift of topic, but I think it will add on this discussion. If you want to unmute yourself, and you have 15 minutes.
Thank you. Hello, everyone. My name is Antonin Hamon, and I am here to present my part of my thesis work at this French-American Innovation Days conference. This presentation will focus on crisis management training, and in particular, the conception of exercise based on repetition learning sequences. Next slide, please. First of all, I would like to present the laboratory in which I am doing my thesis work, the Laboratory for the Science of Risks from IMT Alès in France is currently composed with 25 lecturers and research engineers and with 22 PhD students. It aims to develop multidisciplinary research that brings together researchers from various origins, experience, and skills. The objectives are to provide a transverse and systemic vision for the study, control, and management of risk situations in the face of future changes. The research are gathered on 4 research and development thematic applied on technological, chronic, natural, and health risks. First, the characterization and reduction of hazards, the evaluation of the vulnerability and resilience of the states, the engineering of complex systems in the face of risks, and the crisis management. My work on the creation of a crisis management training course is part of the later theme. Next slide, please. Our societies are regularly exposed to crisis situations due to natural, pandemic, or industrial disasters. These crises can have different natures and intensities. Crisis management teams are involved to overcome these events by taking operational, tactic, or strategic decisions. Any strategic decision must take account of various complexity factors, like time pressure, rarity, or missing information, for example. So, it seems important to prepare the decision makers as much as possible by training exercise. There are various ways to prepare decision makers regarding the different complexity factor of a crisis. This presentation will focus on the training based on crisis management simulation exercise, which are a good way to learn specific skills by experimentation with a limited cost. In this exercise, a group of trainees plays the role of crisis cell and are trained to take strategic decisions by interacting with a group of trainers. Next slide, please. A crisis management exercise can be described as a group of trainers who evolve a crisis scenario by interpreting the decision of the learners. The crisis scenario begins with some undesirable events which have negative effects on the population and infrastructure of a given territory. The realism of the exercise is important in the learning process. During an exercise, learners interpret the crisis cell. As decision makers, they have to limit the negative impacts of these events. To do this, they will make strategic decisions by communicating with the trainers who interpret the rest of the crisis actors, like policemen or maybe army. Trainers will take the learner's decision into account and will report their consequences. In order to evolve the state of the simulation with interactivity and credibility, trainers have to be able to evaluate these complex consequences realistically. Next slide, please. Currently, crisis management exercises follow a linear scenario prepared in advance by the trainers. The learners are guided through stimuli to take the good decisions. It is possible to perfect this learning by drawing on several theories. First, repetition allows you to learn from experiences. The more you practice, the more you learn. Then, you make better progress by analyzing your mistakes. The aim is therefore to create a course that leaves room for the learner to make bad decisions. Then, trainers can go back, replay the scenario, and teach the learners how to take better decisions. By replaying a portion of the exercise, the decision situations are multiplied and it is possible to capitalize on mistakes. However, such a practice requires that the scenarios can be adapted to the various decisions of the learners. In order to adapt this scenario, the trainers have to report in real time on a situation, thus evolution depends on the learner's choices. The crisis situation is also too complex for its possible evolutions to be foreseen by trainers when they write the scenario. Moreover, it is impossible to improvise the evolution of the crisis situation realistically. Trainers must therefore have a tool capable to simulate the evolution of a complex situation with realism. Next slide, please. It is necessary to define the needs to be met by such a tool before starting to develop it. As previously said, to carry out a quality training requires the ability to keep the level of realism of the exercise and to maintain the level of immersion of the participants. These are the needs linked to the quality of the training. But a new possibility, the one of replaying, can create confusion between what is cancelled and what is retained of the scenario when we replay a part of the scenario. So, the trainers have the new need to be able to save the state of all the subsystems of the crisis environment and return to the save at any time. To respond to these needs, the solution of an architecture based on multi-agent system is preferred. In fact, in a multi-agent system, actors are modeled as agents with their own characteristics and behaviors. They are allowed to interact dynamically with the environment like people in a real crisis situation. This multi-agent system can simulate behavior and characteristics of these actors to produce a global behavior sufficiently realistic and precise. There are many ways to develop a multi-agent system. The Gamma platform was chosen to build this simulation because of the agent orientation of the GAMML language and the experience of researchers of the laboratory in this language. The construction of the tool is still in progress, but a first version has been tested during a crisis exercise. The tool already allows to visualize the position and the current process of each integrated actor. It is possible for a trainer to transcribe an instruction given by a learner. The actors then change their behavior according to the instructions and the mean of communication. The instructions are however limited to those already integrated during the coding of the simulation. It is also possible to save the simulation and reload the saved file. Finally, the tool requires a dedicated trainer which can't help the other animator during the exercise to function properly. At this stage, the tools answer the need for the trainers but need improvement to be useful during an exercise. Next slide, please. As said, this tool meets the need for realism. This tool is therefore fed by a system model of the simulated crisis and all its actors. The systemic approach allows to model and to promote a realistic simulation of a crisis. It can represent the complexity of its evolution, the behavior of its resources, and other components of the territory. it is possible to consider the crisis and its actors as a system we call crisis environment. View-by-view modeling allows to manage the complexity inherent to the crisis environment, where the number of systems, their role, and how their behaviors can evolve over time. The four-view make it possible to represent all these aspects. First, the structural view of the crisis environment aims to detail the organization between all the subsystems and their own attributes and processes. The contextual view of the crisis environment aims to detail the exchange services and influences between all the subsystems. The functional view models the processes that describe the activities of the actors of the crisis environment. Last, the behavioral view aims to detail the behavior and the different states of each of the system's components when they interact with each other. The model is fully constructed when all of its systems are described from an organic, contextual, functional, and behavioral point of view. A fully modeled crisis environment meets the need for realism in the training exercise. Next. The new crisis management training is therefore a simulation-based training that allows you to replay all or part of the scenario. This training needs a simulation tool created with system modeling to run in the best conditions. At this point, this training with replay system must be tested to measure its educational contribution. The experimental protocol is simple. A group of learners is divided into two homogeneous subgroups. They follow the same crisis management training with one difference. At the end of the training, one group carries out an exercise with replay, and the other group carries out the same exercise but without the replay system. The exercises performed are based on the same scenario and under the similar experimental conditions. During the exercise, people are dedicated to observing and taking note of the impacts of replay on learning. As there is no final normative evaluation of this training, the performance of the subgroups is measured by survey filed by the learners, trainers, and observers after the exercise. The survey includes self-assessment of crisis management skills and knowledge. They also address the impacts of replay from the point of view of immersion, realism, and learner motivation. The response from the survey and the observer's note are analyzed to identify the nature and extent of difference between the two subgroups. Next slide.
You have 1 minute, Antonin.
So last slide. Next slide, please. I will jump to the conclusion. To conclude on the use of replay during a crisis management exercise, the question of evaluating replay learning will require more and better data to be resolved. With regard to the other impacts of replay, it will be a question of carrying out the usual face-to-face training. I also aim to test and evaluate other forms of replay, such as the possibility of modifying the dangerous phenomenon or replaying exercise several times. The results you don't see in the previous slide shows that the replay have positive impacts on motivation, immersion, and regaining control of situation, but no visually positive impacts on the learning process. Concerning the development of the simulation tool, this development is an important aspect of the replay exercise. Without it, it is difficult to adapt to players' decisions. In order to guarantee the realism of this tool, it is necessary to continue the modeling of the crisis environment, and in particular to compare this model in order to improve it. Finally, the tool itself is still in the development phase, All the necessary functionalities during an exercise are not yet available. Finally, I would like to thank you for your attention during this presentation.